Hello all, my name is naga sarasija, bearing roll number 19BQ1A04F7. Now I am going to discuss the seminar topic of a block diagram of radar in radar engineering subject. Coming to the block diagram of radar, we have two parts, transmitter and receiver. In the transmitter section, we have waveform generator, power amplifier, duplexer and pulse modulator. And in the receiver section, we have low noise RF amplifier, mixture, local oscillator, IF amplifier, and second detector, video amplifier, threshold detector, and finally the output. So coming to the transmitter section, we have transmitter. So here transmitter acts as a power amplifier. We can take it as a klystron or any transmitter amplifier. This generates electrical energy at radio frequency level. Coming to the pulse modulator, the power amplifier such as klystron produces a high power signal which is in terms of megawatts. So the pulse modulator shown in the block, it works as a switch which we can turn on and turn off of the power amplifier. Waveform generator, a low power signal is produced by the waveform generator which is given to the input of the power amplifier. Coming to the duplexer allows a single antenna to be used on a time shared basis for both transmitting and receiving. The duplexer is generally a gaseous device that produces a short circuit at the input to the receiver when the transmitter is operating, so that high power flows to the antenna and not to the receiver. So coming to the receiver section, in receiver section we have low noise RF amplifier. The receiver is almost always a super heterodyne, so it is used immediately after the antenna. This low noise RF amplifier is used to reduce the noise figures and produces the RF pulse proportional to the transmitted signal. Coming to the mixer and local oscillator, it converts the RF signal to the intermediate frequency where it is amplified by the IF amplifier. IF frequency should be in between 30 and 60 megahertz. IF amplifier, it amplifies the IF pulse, and the IF amplifier is designed as a matched filter which maximizes the output peak signal to mean noise ratio. The matched filter maximizes the detectability of weak echo signals and attenuates unwanted signals. The signal bandwidth of super heterodyne receiver is determined by the bandwidth of its IF stage. Second detector, the IF amplifier followed by crystal diode, which is called the second detector or demodulator. Its purpose is to assist in extracting the echo signal modulation from the carrier. Coming to the video amplifier, it is designed to provide the sufficient amplification to raise the level of the input signal to a magnitude. Threshold decision. The output of the video amplifier is given to the threshold detector, where it is decided whether the received signal is from a target or just because of the presence of noise. Finally, and the last element is display. The display is generally a cathode ray tube. A scope provided range and echo power. PPI means range and bearing azimuthal angle. In addition to these, there are other displays like B scope and D scope, etc. Thank you.